Chapter 6 is spatial joins. And the difference between spatial joins and attribute joins is attribute joins are, you have to have a key field, right? And that's the main thing. You need two tables, you need a key field. But with spatial joins, you can join between two feature classes without a key field because your join is based on the location. The other really nice thing or different thing about spatial joins is when you complete a spatial join, it automatically creates a new feature class. So remember when we joined fields, if we wanted to keep that join, we had to export that as a new feature class. Well, spatial joins do that already. Spatial joins also have cardinality. So they have one-to-one cardinality or they have one-to-many. And if you're doing simple joins, then your cardinality is one-to-one or many-to-one. If you're doing summarized, then it's one-to-many or many-to-many. So that's the cardinality issue there. So here's an example of a simple distance join. So I have 2 point files. One is the point showing a city, and the other is a point showing airports. And if I do a simple distance join, the join is going to depend on, or the destination will depend on which field I start with. So if I want to know what is the closest airport to each of these cities, this is going to be my destination, right? So I'm going to start with that. And I want to join one city, one record from the airport. So I just want to find out which is the airport that is the closest to Adair Village. And so when I do a spatial distance join, I automatically get a field created that's the distance, and I automatically append the name of the airport that fits, right? Now, what's interesting is I could have Corvallis Municipal Airport listed several times as being the closest airport to a city. So it's going to be the closest airport to Corvallis and the closest airport to Adair Village. So this may have 5,000 airport names and I may only have 30 cities, but I'm going to end up with 30 features, and each feature will tell me which airport is the closest. But not every airport in my source data could be used. It may or may not be used. So that's one of the major differences in a distance join. A simple inside join gives me blah, 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 blah. So what I want to know is the soil type in each septic that each septic tank is in, right? So I'm starting with this relationship of one septic tank, and I want to know one type of soil, right? So what I have here is a point file showing me each of the septic tanks, tells me where it is, and then I have a feature class that's a polygon that tells me what is the predominant soil in that polygon. So when I start with the soil, so I'm doing an inside job with the soil as or the septic tank as my destination, what I get is appended at the end of that table. It tells me the name of the soil type that is in that septic tank. So in watershed science, we have a bunch of wells in the valley. This would be something that would be really interesting when you're looking at point source pollution and you're looking at drainage to find out for each well what's the major soil type that well is in. And this is the way you would do that. You would do a simple inside join. A summarized join is when your cardinality is different and you have a one-to-many or a many-to-many. And so with a summarized join, I'm going to go back to that airport thing, and I want to know how many cities are closest to each airport. So this time the destination is the airport, right? And my summarize, or my source is my cities over here. So I have a one-to-many cardinality, and so there are many cities that are closest to that airport than to any other airport. So what happens when I join this table, do I have that there? Yeah, so here's the result of that summarized join. It tells me that there are 31 cities that are closer to Malone Sweet than any other airport in the state, right? Or any, yeah. And there are 33 cities that are closest to Corvallis than any other airport in the state. And I can also use that to summarize all the population. So I can get the summary of the population for all 31 cities, and I can get the summary of the population for all 69 cities in Portland. So the summarized join looks a lot just like going through and summarizing as we did before based on one field and adding up the other. So a summarized join will always give me a count of how many features were near that one particular other feature or in that one particular other feature. So this is a summarized distance. So all I want to know is how many are near there. One of the things that you want to think about when I do a summarize or a spatial join, I'm getting the attributes of the source feature appended to the attributes of the destination feature. Okay. Yeah. No, not at all.
When they say the distance of cities, do they calculate the center of the city then, or what is the landmark
Okay.
for that distance?
Great question. So what they're doing is kind of as the crow flies distance. That's just the default. So we're not going down the roads. We're not, figuring elevation. There's no cost involved. If I have to go around the river, I'm just saying from the center, from this point to that point, as the crow flies. If I were doing it to a polygon, I don't know if, I think it does the centroid of the polygon, yeah, out to the next point. So you can do more detailed analysis where you pick the edge of a polygon because that's what you really, that may be the flow rate or the end of a flow and you want to know where that goes. Great question. The book has this nice little chart in here which if I were taking an exam, I would write that down for myself. So it looks at the two basic types of joins, inside and distance, opposed to simple and summarize. So the cardinality is here and the types are here. And so if I have a simple distance join, I'm going to get how far the closest hotel is, right? It's going to ignore all the other hotels and just say, well, this one's closest, it's that far. If I'm going to do a summarized join, then I have to switch and say how many attractions are near this hotel, nearer to this hotel than any other hotel, right? So then we can look at the inside. This is which county is in each school. So I'm going to start with the schools on this one.
I'm pretty sure we don't keep counties and schools.
We don't keep counties and schools, right. So let's say I have a list of schools and I want to map them, the school name with the county name after that, and I don't have that in the table. So I could grab that by doing a spatial join, schools, and grab the county data, and it'll give the name of the county for each school. If I want to know how many schools are in each county, then I need to do the other way where I get a count. So, you really need to think about, do I want to count? Is it telling me how many airports are near this city, or is it asking me what's the nearest airport, right? So those are two different things. That's a distance versus simple versus a summarized. So you really need to kind of work through that algorithm of what you're looking for. One of the things to remember is that the destination and source are really important, and whatever your destination shape type is, that's what your output's going to be. So if I start with a line and I add point data, I'm going to end up with a line. If I start with a polygon and I add line data, I'm still going to end up with a polygon. So whatever your destination is, that's what your output feature class will be. Really, really important here, and I had a student again say they didn't know what a CGS was. This will come up all the time and it will haunt you, and you will not be able to use your measuring tool. You will not be able to get accurate results, and you won't know why. You cannot do analysis in a geographic coordinate system. If your data is not projected into some kind of units where it's using meters, feet, inches, whatever, you can't do any analysis because the distances are in angular degrees. And so a geographic coordinate system is the base of every projection, but the projected coordinate system have gone that extra step to adjust for where we are in space. Okay. Let's see. Oh, there we go. So that's I googled CGS, and this is the result that I got from ArcGIS Online Help. Okay. So when I look at the coordinate system, so let's say I'm trying to measure something and I get outputs that are weird or it's not working. One of the first things I do besides rebooting my computer is I look at the projection. And so here I am opening up the preferences in the data frame properties of that layer. And it's saying here that it is a geographic coordinate system, and there's the datum. There's no projection information here, right? So this data is based on latitude and longitude. It's raw angular data. There's no linear measurements here. This data frame has been projected, and it's coming from what you see is that it is based on the geographic, it's based on the same coordinate system, but here's the projection information. It's been projected into a Lambert conformal conic. The linear units are meter, right? So you really need, I would encourage you, before you do anything in GIS, open up your projections and your properties and just see what your projections are. And if you're working in a geographic coordinate system, I would export that to a feature data set that has a projection. Okay. So she goes through this great little test for deciding what you need to do. And this is really helpful when you go through the exercises. But anyway, the first question she's asking, or you should ask yourself, is what is my destination and what is my source, right? So what do I want to end up with? So the question is, what hospital should each school use for an emergency, right? So what do I want to end up with when I'm here?
Simple. One.
Okay, I want a one-to-one because I want each school to have a hospital listed, right? So do I want to end up with hospitals or schools? I want to end up with schools. So schools is going to be my destination, right? And I want to take that hospital name and add it to the back of my school attribute table. So now I can query any school in my database and tell you which hospital you need to send that kid to. Because I want the closest hospital, assuming it is really the fastest, right? We're just going to assume that right now. Okay. So that's the first question. I have to go through and figure out what's the location, what's the direction I want to go. So this is each school, and this is the distance they are from a hospital. So that took that school information. It gave me a distance field plus the name of the hospital, and then I put in I mapped this by the hospital data, or by the distance data. For a distance summarized school, I would have to do this a little differently, and I would say how many schools are closest to each hospital, right? So now I need to summarize because I need a count of how many schools. So hospitals has to be my destination. So now I've got a one-to-many, right? And so I've got many schools that are going to be added to that one hospital. So now I know I need to do a summarized join. And so when I open up the joining toolbox or tool, I can see that schools is my source because I've right-clicked my hospital and I've done a join. And so then the box comes up. It knows that I'm joining two hospitals. So I choose my drop-down menu. I want to choose schools. And I just want it to give me the sum, which gives me the count, right? I don't want to know the average school. I just want to know, I don't even know what that would give you. I guess if it were population, it would give you that. And so here is an output of each hospital has the number of the closest schools, right? So this hospital has 15 to 20 schools that are closer to it than any other hospital. That hospital has 1 to 3 schools that are closer to it than any other hospital. And the little blue dots are, of course, the schools. So you can see that I can make that join, and then I can also map my new results. So this one I'm mapping the count. This one I was mapping the distance field. Okay, so because this is the good news and the bad news, ArcGIS creates a new feature class for you automatically, and it will call it, I don't know, Spatial Join 1, Spatial Join 2, Spatial Join 97, Spatial Join 137. So unless you stop when you get to, I don't know if I showed you that here, down below this, then that tells you where do you want to put it and what do you want to call it. Make sure it doesn't go into your default geodatabase and that you know what you've called it, right? And I often keep a little log of what I've done. You know, I've done hospitals as my destination, schools was my source, I called it this, and then I find out, oh, that isn't what I wanted. So I remember what I did and what I called it. Okay, so this is her little algorithm or little thinking process. What do you need to know after the reading question? Open the data tables. Okay, so one of the things I always do is I open my attribute tables and take a look at data. I have never worked with data without really seeing what is in those attribute tables so I have an understanding of what it is I'm trying to do. And then, you know, I have to think about what it is I want to map when I'm done or what information I'm looking for. So that helps me know what's my destination. Now, do I want a count of things? Do I want a distance? You know, so do I want to join the name of the soil onto the back of the school? Then I want an inside join, right? If I just want something that has to do with miles or distance, I want a distance join. And then I've got to look, am I doing simple or summarize? So this is the number of earthquakes in the congressional district, okay? So I have a file that's just points that shows earthquakes, right? And then I've got polygons that are congressional districts. And so what I want to know is how many earthquakes are in each congressional district. So what is my destination? Right, I want to end up with congressional districts with some number of earthquakes for each congressional. So earthquakes is my source, congressional districts is my destination. Oh, I have that right here. Wow, I think this was supposed to show up later after we discussed it. Anyway, yeah. All right, so the cardinality is there are many quakes that possibly in each district, right? So I know that I have a one-to-many. So I know I need to summarize and I want to do a count. All I need is the count, how many, right? So we'll just go through these. I'll just read them to you because they're right here. Okay. The other one, she gives you an example of population risk of rivers on county population. Okay, so I think the idea here is if there's a lot of people living near a river, the river gets polluted, so I need to know how many people are living near each river, right? So the destination has to be river because I want to know how many people are there. And the county population is my source. Again, it's a one-to-many. And again, I'm going to summarize, right? So I'm going to end up with each river and how many people live along that river. Okay, la la. Is this sounding fun yet? I think this is fun. Okay, and then the last one is closest volcano to a city. Okay, so 2 points, files, volcano and city. Which is closest to each city. So almost the way these are worded, you can usually take the last one as your destination. I don't know if that's always true. We could see that if that works. So I want to know the name of the volcano that's closest to each city. So city's my destination, volcano is my source, and I just want a distance, right? And I want a one-to-one. I don't want to know the name of all the volcanoes that are close to each city. I just want the closest. So it's just going to be a simple join. Okay. All right. So here you go. Let's just talk about this a minute. Some examples. How many buildings are in each watershed? So I've got a point file called buildings and watershed polygons. So Sam, what's my destination here if I want to know how many buildings in each watershed? Yeah, I'm going to end up with watersheds, which are a polygon. Buildings are my points. Am I going to do a summarize an inside or a distance? Summarized inside. Right, summarized inside. Perfect, yeah. The closest liquor store for each bar in a city, because I want to go get that tequila quick and get it back for the customers give up. Okay, so this is a real world example of this data use. So I have a point file called bar and a point file called store. What do you think, Eric? So I want to find the closest. So I'm dealing with distance. Okay, so when I want to find the closest, that's a clue. All right? So I want to find the closest liquor store to each bar. So what's my destination? The bar, yeah. Because I want to be able to pull up that bar and say, go to that liquor store, right? So that bar is going to be my destination. Liquor store is my source, and I'm going to do a simple distance join, and it will tell me how far that closest bar is. That's all I want, right? Okay, what type of zoning for each type of fire hydrant? These are real things. So Tim, I've got a point file called hydrant and a polygon with zoning. What would you do with that one?
I'd make hydrant my destination source.
Yep, okay, so hydrant's my destination, and zoning is my type.
Which point up?
And do I want
A minute to one.
do I want inside or distance?
Looks like an inside.
Exactly, because I want to know the name of that zoning, right? So I'm going to pull that information from the file. I don't care how many, because it's one. That's all I want. Okay, Siobhan, you're up. How many cities and the population are closest to each train station? Ooh, so there's a little hint right there, because I'm asking two things. Yeah, which one's going to be my destination? No. How many cities and population are closest to each of these things? So this is what I want to end up with, the train station. So I got a point called train station. And now I want to know a count of cities, right? I want to know there's 8 cities, and then I want to know the total population for those 8 cities. So I'm going to do a summarized distance, right? Because I want to summarize that information, and I want to know anything that's about distance, length, how far, you can know that's a distance, right? If I don't want to just know the name of one thing, then I know it's got to be a summarized, okay? So she'll work you through in the tutorial how to do each of these, and then for the skills, or for the what are we doing next? We are doing the spatial joins. Oh, here it is. Hold on. I don't want you to do all of the exercises. I want you to do exercises 1 through 8. And for number 5, I want you to make a really nice map that's on 11 by 17 template, okay, with a good design. That is a great map to use for a resume portfolio, because it gives you, there's a lot of analysis that goes on in that map, and it gives you a lot of room to kind of pull in other data and make a really nice layout. So there you go. Any questions about that? That's a whole new way to kind of think about things, but it's not completely new.